Hi everyone, welcome to the class of MBA CAT Fast Test. This is Shubham Jaiswal and today we will be beginning our session with a series of videos which are basically the rough outline of the concepts you are expected to know in before you appear in the examination. You can just call them as a concept overviews. So we will begin with the topic numbers. Numbers, as you know, can be classified in basically two ways: real numbers and imaginary numbers. Now, imaginary numbers do not constitute much of a portion in the examination, so we will come to it when it will be required. Right now, we will be focusing on the real numbers. Real numbers can further be classified as rational numbers, as you all know, and an irrational number. By the definition, we might already know rational numbers are the one which can be represented in the form of p by q, and irrational numbers are the ones which cannot be represented in the form of p by q. This is one part of the definitions. I will elaborate it further. Now see, rational numbers are basically the ones which are terminating. मतलब either they do not have a decimal point, which a whole number they are, or even if they have a decimal point, they gets terminated after a certain value, 2 values, 4 values after decimal, 14 values, and even if they are not terminating, then they are repeating. Which means ki if they are not having a fixed end after the decimal points, like in here the screens you could see 0.88, 0.38787, this can continue forever, but there is a pattern, they are repeating. So they are either, if they are terminating, that's fine. If they are non-terminating, then they had to be repeating to be classified in the criteria of the rational numbers. Now, in the case of irrational numbers, what are irrational numbers? So they are basically which cannot be represented in the form of p by q is one part of the definitions. Another part is basically when they do not repeat after the decimal points, then they are called irrational numbers. Like you can write any number 0.23578746, and you cannot just continue the pattern, so that will be your irrational numbers. Another irrational numbers we can say is root 2, root 3, root 5. Now, so these are basically irrational numbers. Now you might have heard of a number pi. Pi is 22 by 7. It can be represented in the form of p by q, but since it has non-repeating digits after the decimals, it is classified in the irrational numbers. Okay, so getting the concept, irrational number is basically are the numbers which cannot be which are non-repeating, and they are non-terminating. Okay, now if you are wondering how can this 0.88 be represented in the form of p by q, this you can easily see this, and this the value of point, this can be represented by 8 by 9. 3.8787, this can be represented as in the form of p by q. This will be approximately 384 by 99. If you are wondering how this is derived, let me show you how by explaining this one. Let's consider this number at like an x. X will be equal to, consider this number 14.5673. Now what you need to do to convert it in the form of p by q is you need to cancel the digits. Basically you need to focus on these digits, that this can be, how this can be cancelled. So the one way is you multiply some number with this, some number with this, and the another number when subtracted or any operations is done to that, that gets diminished. This decimal parts get diminished. So let's say I multiply 100, because you see two decimals are there. If another number is multiplied of same quantity, then it will be getting eliminated. So if I, this will become 100x, multiplying 100 both sides, this will become 145673, and this gets repeated. So if you subtract this, consider this as equation 1, consider this as equation 2. So you do equation 1 minus equation 2. What will come? This side it will become 99x, and this side it will come 1456 minus 14. This will become 1442, and this side is 73 minus 56, it will become 27. Okay, and then 73 which are repeating, these parts get cancelled. So and this side we will getting approximately 99, so you divide this by 99. So you are already getting this in the form of p by q. If you cancel out the decimal part, this will become 9900. So this is how you can represent any rational numbers in the form of p by q. That's how this, and that's how this is done. Okay, now moving ahead. Important things to remember in numbers. See, these are the concepts behind every questions in the examination. They will not ask you explicitly, but they are hidden somewhere. See, natural numbers begin with 1 and whole numbers begin with 0. As the name suggests, whole numbers, it starts from 0, and natural numbers, it, just you remove the 0 part, and the from 1 it become natural numbers. You already know this from class 6. Now, negative numbers plus whole numbers are called integers. Now, what are these basically? Consider this point as 0. From here, it becomes whole numbers. And if you remove the 0, then this becomes positive numbers or natural numbers. And if you include this negative number plus whole numbers, this whole becomes an integers. Right? Moving ahead. 0 is neither negative nor positive. Remember this point, we tend to forget in the hurry of examination. 0 is not negative. We will continue this. We have other points as well. Now, odd or even cannot be negative. So definitely you might not have heard -3 is an odd number or -6 is an even number. So this is the reason behind it. Now, prime numbers can have only two factors, the one and the number itself. Okay, so the prime numbers are 2, 3, 5, 7. So they all have two factors. Now, composite number have three or more than three factors. Now see, the first composite number you would have already guessed. After 1, 2, 3, 4. 4 is the first composite number. 1 is neither prime nor composite. See, the to be classified in prime, it must need two factors, and composite, it must need three factors. So it has only one factor, 1. So it does not classify in any of the sections. Right? Moving. 2 is only even prime number. He has the privilege of being an even and prime number as well. Positive solutions, now see, this we tend to miss the things given in a question. Positive solution of an equation or anything else is asked. Positive solutions means it must be starting from 1, 2, 3, 4. You cannot include 0 as the solution of the equation. So that's why I have especially mentioned positive solution means solutions, okay, values can start from 1, 2, 3, 4. Now, non-negative solution. Again, highlighting this point only, basically, ki 0 is neither negative nor positive. Non-negative solutions, which means ki negative numbers are eliminated. 0, 1, 2, 3, 4, you can take it out. Similarly, negative solutions means you can have values till -1. Again, why? Because it is asking negative solutions and 0 is neither negative nor positive. Non-positive solutions means solutions can have values till non-positive. See, again, it is asking non-positive, which means it must not be positive, and 0 is neither negative nor positive. So it has, this is the point generally which we tend to forget. Negative, so we will remember ki non-positive, which means will be negative. Now, these are another things, even plus even. This you can try to remember, odd plus odd, even, or you can also do in the examination odd plus odd. If you need to check 3 plus 5, 8, the answer is coming even. So it will be for every numbers, even any number into a even into any number, because it will have two, so it will convert into the even. And similarly for all, you can check it. You don't need to remember this thing. You will get it by practice. Now, prime numbers. We will be now focusing on prime numbers. You must remember the things. Between 1 to 200, there are 46 prime numbers. This does not matter including this or excluding this, because 1 is neither even nor nor prime nor composite, and 200 is composite. So you can remove the barrier from that. Now, between 1 to 200, 46 prime numbers, 1 to 100, 25 prime numbers are there, 1 to 50, 15 prime numbers are there. Now, the largest two-digit prime number is 97. The another choice which we have is 99, which definitely is a multiple of 3. Largest three-digit prime number is 997. Now, see, you might have been thinking if 999, so it is multiple of 37 and 27. Smallest three-digit prime number, you must remember it is 101, or of course you might know it. Now, smallest four-digit number is 1009. Now, if you want to ring, you could have confused in the examination between these, but 1001 is a multiple of 13, 7 and 11. But remember this, this will be your friends in the remainders topic as well. 1003, it will be a multiple of 17k. 1007, it will be a multiple of 19k. Okay. Another thing, moving ahead, smallest 5-digit prime number. This is a multiple of this. This is 10007. Okay, you can remember this thing. If you do not want, you can just ignore this. If you are thinking, then what is a multiple of what about 1001? This is not a multiple of 3. You can directly see this. So I would like to tell you that this is a multiple of 137 and 73. Okay. So this is and similarly it gets on continues. Now continuing. Prime numbers 1 to 25, you must also remember which are the 25 prime numbers. So there is a way, I think this will help you to remember them. In all the tens which can be classified, there are two tens which can be which has fours, and they are the first twos: 2 3 5 7 11 13 17 19. Now there are threes and they have a difference of 3 as well, 4 and 7. Okay. So this line 41, 43, 47, 49 is a multiple of 7, and here 71, 73, 77 is a multiple of 7 again, and 79. So you can remember that there are only three lines which have 3 prime numbers, which are this, and the rest of us have 2 prime numbers, each in them 23, 29, 31, 37, 53, 59, 61, 67, and so on. And there's the last line of 90s which has only one prime number, and it is the largest second digit prime number, 97. Getting? Okay, moving ahead. Now, how to check a number is prime or not? So, now, you can check the prime numbers are always of form 6k plus 1. So number you want to test, you just test it whether it is 6 plus 1 or minus. If it is not classifying this area, then you can definitely be sure it is not a prime number. If it is classifying this area, then you need to check further, right? And the reverse is not true. Because now p square minus 1 is always divisible by 24. This is the perfect test which you can do after this. If it is classifying this, you just square it and subtract from 1. If it is divisible by 24, then you can say 99% that it is a prime number. Now, digital sum of a prime number can never be 3, 6 and 9, or else it will be divisible by 3. It will have more than 2 factors. So that's why. Check the number to be divisible by prime numbers before the root of that numbers. What this means to say, if you want to check number, let's say you want to check for 119, whether it's a prime number or not. So it will lie where it will lie between its root will lie between 121 and 10, which means you can check before prime numbers before 10. So you just need to check whether it's a prime or not. If you can just need to check with 7, 5, 3, and that's it. If this does not gets divided by this, then it's a prime number. Okay, fine. Moving ahead. Now, sum of first n values. This is a basically summations. You must remember is sum of first n values is n plus 1 by 2. Then sum of squares of first n natural numbers n plus 1, 2n plus 1 by 2. This is a formula. Again, n cube, 2 cube, n cube till n cube. The formula is n into n plus 1 by 2 whole square. Okay, now the sum of first n odd number 2n minus 1 odd natural numbers is n square, and for even it is n square plus n. But always remember that whatever this is not the complete. Suppose if you want to find off the value of odd natural numbers till 11, you just don't put 11 square, you just find out at what place the 11th will come. Let's say what is the number of odd number of 11th. Basically, let's say you 11 plus 1 you do, and you divide by 2, it will become 6. So 11 is sixth odd number, then you put the value 6. Similarly, you can do for even as well, right? Okay, then we will continue factorials in the next video. Since the aim is to keep the video short and encompass as much as concept as possible, so we will be continuing factorials in the next video. I hope the learnings helped you. Thanks for watching.